Well, welcome all. We want to welcome Koen Vossen. He's going to talk about Ingestify, Rethinking Ingestion for complex data.
Yes. Thank you. Yes, you can see this is also PySport related. I'm one of the founders of PySport, and we are trying to just take over the entire conference. And I think it's going pretty well. Maybe you've seen before, but I'll do some PySport advertising here. So we do bring people together, unite practitioners, researchers, learners, build a super cool community around sports analytics. Maybe you already have seen some of the talks in the PySport track, but yeah, we always try to build a bigger community. What are we looking for? What do we do? Well, donation sponsors, we already have some, like Skill Corner, Impact. We support open source, we do meetups, and conference as well. One is kind of today, maybe we have PySport conference next year, we never know, but I think today is already pretty cool. If you want to contribute, what's like similar to what PyData always is looking for, but we are also looking for sponsors, hosting a meetup, contributing to open source. So if you're into sports analytics, I think, well, this is something I want to help with. Always welcome. Yeah, and today, Ingestify, rethinking ingestion for complex data. It's good to first go a step back, because this is something that professional soccer clubs use to prepare for opponents, for example. So they get all kind of event data, and this is where recovery map means if you lose the ball, on what side of the pitch do you recover the ball? And you can imagine you need some data for this. But there are some challenges there. So there are all kind of providers of data, depending on the league you're playing in, and they use different formats. So one can use JSON files, the other one XMLs or whatsoever, and they use different sizes of the pitch. So you can imagine that if you take a penalty, this is different coordinates than this one, etc. And a lot of clubs have like a one-person data department, and then it's really useful to have some open source software that solves this issue. So that's why we started with Kloppy. And you can see we can put in all kind of formats like XML or JSON or whatsoever. It will unpack it and standardize it. And in the end, for the data scientist, it's super easy to use this data and don't have to spend time on thinking about how to parse the data, how to standardize it, and you can just focus on getting impact for your team. And I really thought we kind of solve data engineering for football clubs with this package. And we had several talks with people at clubs explaining how this works, and it helped them. But in the end, I also asked them the question, where do you store your data? And it's several different answers, but the one that scared me a bit was on my laptop. Okay, sure, that works. So Kloppy solved the problem. It could easily parse and standardize the data on his laptop. And we had some more conversations with other clubs, and another one, I think it was from the Netherlands, asked them the same question in the end, where do you store your data? And luckily it was not on his laptop, at least I thought it was luckily, because he said it's on the laptop of my colleague. It's like, okay, sure, there might be something there. But in the end, I think it's the entitled notebook all over again. It works on my computer, the data is on my computer, maybe even on someone else's computer, but there's no central place for data. And if you're running a one-man data department, yeah, it's complicated to do it. But luckily, there was also one of the clubs that put all their data in a central place, and it was like a MySQL database. And yes, it works, but when data grows, it might become an issue. And I think there's also a bigger issue. I create this image somewhat myself, so normally it asks for cheeseburgers, but in this case, this cat is asking for rows. So what actually happens a lot is that we try to squeeze everything into rows, because, well, a MySQL database likes rows, like other relational database likes rows. But the question is all data like row-based? And this is some actual data we get from the German competition. This is an XML file, and as you can see, there's already some hierarchy in it. We have some players, we have training staff, we have some officials, and this additional data to event data. So then the question is, okay, can we just squeeze this into one data frame, or do we need something else? Yeah, this some random files I found on my laptop. Yeah, but this is actual data that's used within sports analytics. So XML files, this with positional data, but an XML file of 4 megabytes. Video files quite often are used, and this probably also positional data, but what kind of format I'm not entirely sure. So I was thinking there might be data that's not really suitable for just rows. And if you look at different domains, you might even find this kind of data, like MRI data, which, well, you could try to squeeze it into rows, but it doesn't really fit. So my question is, are we just trying to squeeze everything into a form that's not, yeah, maybe it doesn't really fit? Another question I was having, at least when I look at how people are often fetching data, is something similar to this. It's quite a basic example, but so for all match IDs, you get data from some endpoint, do some transformation, and then store the data. But I believe there are some issues over here. And one is, what if transformation takes quite a while and heavy CPU? So then we could use like a large CPU machine, but we use the same one to fetch the data. That might also take a while. So then we're wasting compute on fetching data. And this is one of the examples that I used. So this is skeletal data, also from football. So you get the joints of all players, 25 times a second, and data, it's probably in JSON format, it's 8 gigabytes, so download with an, well, okay, connection takes 3 minutes. And if you want to parse the data just in a single core, it also takes 4 minutes. So there are different resource needs on those both steps. So if you split it, I think on the ingestion side, it's mostly I/O bound, which normally is pretty cheap, and parse is more on the CPU and memory side. And it's something that's important to understand, that you don't want to waste service that is super expensive on ingestion, and maybe have tasks that take very long because you use a cheap ingestion system. And lastly, at least also in football, but I also worked at a big marketing agency. A lot of APIs, etc. They work sometimes. They're slow. They give all kind of errors. So it's always best to have your data as soon as possible within your own environment, and then continue processing it. And that's the thing that we try to solve with Ingestify. So how does this work? The source on the left side, this is all football related data. So in some place you get an FTP server where you have to fetch the data from. StatsBomb is one of the bigger suppliers of data. What happens is we get a configuration. It will define all tasks that it needs to fetch. It will fetch the data and it store the files directly on S3 or local system, or it will store the metadata. So in the end, you get like an organized way of storing all your data, which makes it easy for downstream applications to process this data, because it's pretty easy to fetch, for example, all matches from a single competition, because that's part of your metadata. And also, this one does not transform the data at all. It will just store it as it is, which allows downstream applications to just pick up the data from your object store and do the processing there. And you could easily scale it out to multiple workers, while you just need a single cheap node to do the ingestion. I thought let's do some demoing, and I hope it works, because I will do a live demo. It worked at my laptop earlier, but we will see. And just remember, don't forget, just scan the QR code. Let's get friends over there. Let's see. Can we all, is it a bit readable also in the back? Yeah. Okay. Yeah. So what the base is like a config file where you could specify where's the metadata stored. It uses SQL Alchemy, so everything that SQL Alchemy supports is also supported here. And where you want to store your data, can be a local file or S3 or whatsoever. What's not shown here is that it also has integration with AWS Secrets Manager, so you could easily use credentials from there without passing it in your config files, or even have to specify it in your environment variables. Right now it's only AWS, but you can imagine it's quite doable to extend it to other stuff. Then you have to specify the sources. In this case, we'll use the StatsBomb GitHub source. That's open data that's available for everyone to play with. So if you want to play a bit with football data, that's a nice start. And it defines ingestion plans on how to get data and what data has to be fetched. So in this case, it works with selectors. You could just define which competitions to get, which seasons to get. We could also change it to like this style, and then it will fetch all matches where competition ID matches 11. But for now, let's see what happens. I can just Ingestify run, and then by default it will pick this configuration. It will start downloading, and it's done. So it's executed 35 tasks, and it got all the data. Oh, connection, that's fine. So in the end, it works with data sets and revisions. So data is always immutable. So also for downstream processors, you always know what's the exact data that you're processed, and it's easier to have it traced if there are issues. And when I run it again, now it tells me that it successfully ignored 35 tasks. So it detects that there are no changes, and then it doesn't have to do anything. And I think what's also interesting, and that something we are also using at one of our football clients, is that we integrated with a Kafka queue. So after ingestion, it will put an event on the Kafka queue, and then downstream lambdas will pick it up and will process it. Let me just run it again. Oh, yeah. So now in between, it emits those events, and I define it over here, so I can just specify this one, and when a data set is created, so the first time you'll get an event, and when a revision is added, you'll also get an event. So you will exactly know what files are changed, and if you need to process it or not. What's important in this one, let me also show you the source of the source code of the source. So it has like a find data set, then it will just ask the source what kind of data sets there are. It will define what needs to be fetched. And important here is that it will always use things like a last modified to prevent fetching data that's already there or what didn't change. Because you can imagine if you, for example, get tracking data for entire competition, it's kind of a waste to refetch 50 or even 100 gigabytes of data every day because, well, you don't know if it changed. So it always tries to ask the source if data actually changed, and if not, don't fetch it. And when it stores the data, at least just before storing it, it will also compare it to see if the data actually changed. Yeah, in this case, I imported data for competition 11. I hope 11 and 90. Yes. And in this case, I can just run read data. Oh. And then it will return for this competition the data for each match. And as you can see, it's just raw data. It doesn't know anything about the content, only that there is a file which has a key called events, and you can read it. And in this case, because we also have an integration with the Kloppy data set, let's just do a single one. So this is the raw data, and then it's converted into a Kloppy data set where we can do all kind of stuff like filter. We only want the shots that were a goal. I'm not sure if it has actually one in. Oh, there are 2 goals in a match. So then it's quite easy to go from I want all matches for a single competition for a season to I want all goals within those matches. But in this case, I had to run Ingestify before I had the data. Sometimes that's not really what we want. So it also has an option to do auto ingest. In this case, it will you don't have to run Ingestify yourself. It will just figure out what data is missing and fetch it, store it in your object store, and then return it. It should work, right? Fingers crossed. Oh, and actually it's storing the data on the database 2 instead of the one if you thought I was faking it. But then it refetched the data, stored it. Oh, you could also see it successfully. 35 tasks is executed and returned the data. And in case you're running, fetching more data, it's actually nice to already process it while it's downloading the data. So then you can pass the streaming. Yeah, sure. I need to fix some typing there. But it's actually working the same way, except for that it will emit data sets as fast as possible. So when it synced one to the object store, to the meta store, it will be returned right away. Hopefully we can see it a bit. Oh, it went pretty fast. Okay, let's do some more. Yeah, so now it keeps downloading it and keeps emitting new data sets. And then the next time I will run it, it will already fetch whatever is there. Also check what's changed on the source, resync it, and then emit again the new data sets. Small question, yeah. Oh yeah.
So looking at your code there, so it works based on providers, that's one. Is one of those.
Yeah.
But it looks like Ingestify here already knows some context or like about what that should look like. So for example, it has a competition and it has a season ID.
Yeah.
Does that live in Ingestify itself, or is that something out of the book?
No, this is part of the source. So in the source there you define competition and season ID, but Ingestify does not know anything about it. It will just pass config and put it in here.
So at the source that you have to define this schema or the structure of the data.
Yes, you have to define how to get those competition and season IDs. In this case, some providers also have a list of competitions, and then you don't have to pass it and just tell it to fetch everything. And then this one will get all the competition IDs, all season IDs. I didn't include it here, but you could also even pass last modifiers here, and then it will skip an entire competition season based on the last modified. And then if you, for example, this is also used at one of the bigger clubs from Belgium. I think they have to sync like 80,000 matches that can be changed, and then it runs in like a couple of minutes because it can just skip a lot of data. Yeah, and last but not least, there's also open data available, and then you just have to say, well, I want StatsBomb open data. Ingestify knows where to get open data from. So if you want to start playing around with football data, you don't need to specify a config. You'll just tell it, well, I want my data, my metadata over here, my files over here. Do it in a streaming fashion and use the open data. In this case, I will also start running data. Oh, it's a bit of a spam, right? Oh, stop. And then here in between, right? Loaded. Is that loaded? Yes. So you'll see in between it will show that the data is loaded in the streaming fashion again, and then you can start playing around with it. In this case, it might be also. Wait, let's see. Dev parse. This already kind of shows how to decouple. Oh, that's nice. Okay. Oh, great. In this case, well, it's way faster because it also allows to do multi-processing using this data store. And this is just running on my laptop, but the data is stored, could be stored on S3 with, for example, a Postgres somewhere. So everyone is looking at the same data, and when it's ingested on my, using my computer, it's also available for the others. And then, yeah, we are pretty fast back to the happy place, where we are not depending on external providers. So that was my story for now.
Thanks for the talk, Koen. Are there any questions?
Thanks for the nice talk. I was wondering, are there just any open source tools available who do this doesn't sound like a very specific task to me.
Yeah, that's a really good question. I did quite some research on this, and I think the thing that was what I found was mostly it's based on rows. So tools like DLT or Singer, they force you into converting it into rows first. But I think a lot of data does not fit in rows, and there the ingestion and the transform are coupled because it has to return rows. And for example, in the case of the skeleton data, you have to spend quite some time on processing it to get to the rows, but you might want to scale it out in a different way. So yes, there are tools that do similar stuff, but different.
Okay, thanks.
Any other questions?
Thank you for the talk. A question, what if the data is not up to standard? Do you also account for that? So for example, if it doesn't fit the schema when you're parsing data?
Yeah, it's a really good question. Right now, and it's something which is still being implemented, is partly there. So for the revisions, it has a state that still needs to be validated. And then you can run additional checks and mark it as invalid or whatsoever. But that's on the revision side. So yeah, it's almost there. Yeah.
Thank you.
Any other questions? No. Then I want to thank you again for your talk.
Okay, thanks. Oh, yes.